got to get it going. And what I think I'll do is, if you sat through my first two sessions, the keynote session as well as the OpenShift session yesterday, you've seen a lot of the crazy stuff that I do. Though I have a whole new demo, completely different demo that I want to walk through, and it's actually going to be kind of tedious and take a little time. Meaning we're going to walk through the code in some detail, kind of look at it, talk about it. And it's more for just kind of showing you what a reactive system might be like, or a reactive application might be like. It uses a technology called reactive messaging, which you may or may not have heard of, because it's kind of new, right? It's a new API, if you will, for building reactive applications. It's part of the Quarkus as its foundation. But we're going to kind of focus on that for a little bit, because it's kind of cool what you can do with it. Okay? And as a matter of fact, let's see if it's running right now. Here in the background, let's see if this is working. Or not. Let's see that one. Okay, that's the output side. Basically, there's an input going through a Kafka topic, and this is JSON input going through a Kafka topic, being displayed by different services, and then going through a transformational piece of code, right? Inbound, transformation, outbound, and that transformation is this side of it. So let's see if it's still working for me here. Yep. So basically, if you can kind of see it, it has this basic order structure in JSON going in, with item ID, item, description, quantity, price. Out the other end, it adds a little special K customer. It's just flagging that customer is special, and it's doing the extended price, right? So it's trying to do the math of the quantity times the price and giving you the extended price. And this is just my example. I used to do a lot with warehousing, distribution, e-commerce. So order processing, customer processing is kind of where my head's always at. So, these are the kind of things we would have to do, right? You'd have a basic data payload coming in from some source, and your job primarily was to take that input, munge it up, tear it up, rip it up, modify it, and put it back out some other place, right? So this is not a pure online transaction processing system, OLTP. It's more of a transformational processing system, or even a batch processing system, depending on how the input and output is being structured. You could do this with a Camel, or Spring integration, or Spring data flow, things like that, right? Camel's a pretty common thing. But in this case, we're going to show you just kind of Java way of doing it, right? Because I actually find that a lot of people just write Java code for this type of use case. So we'll come back to this as when we get through with this presentation stuff. So we got to entertain you for a little while first, okay? So the first thing is, at the bottom of the slide there, you'll see my Twitter handle. You can find me if you have questions at Twitter pretty easily, as well as the bit.ly link to this slide deck. So somebody's going to say, hey, can I have access to the slide deck? Bit.ly link to the slide deck. And when your neighbor says, hey, how do we get the slide deck? Because someone's going to ask sitting to your left or right, you can say, the Bit.ly link to the slide deck. I make this point because for some reason, at the end of the session, 4 of you are going to walk up to me and go, can I get the slide deck? And I'm giving it to you now, okay? Now, you have it. Just load that up on your phone even. You'll pull it into your phone. It's a live Google Doc. If I make changes to the presentation, which I did today, you'll see those live changes because it's a live Google Doc. I decided if I work for an open source company, even the slide deck is open source. Everything is open source. Okay? Let's get into this. Let's have some fun. Now, how many people here have already spent time in this conference at a Quarkus presentation? A lot of you. All right, fantastic. Did you guys see Edson's presentation earlier? Okay. I'm not going to show you the same APIs he did. I have a different set of APIs I want to focus on, but still reactive. He did a reactive session. He kind of focused more on the reactive data interaction, right? Data access, things like that. I'm going to show you reactive messaging and the streaming technology, because that's what I'm interested in. So the good news is you'll see something hopefully completely different. If not, you can kind of blame me and Edson for not coordinating better, because we work together. We should know. All right, let's dive into this. Okay? I like making this point right here. I was part of the Atlanta Java user group community for many, many years. I ran the group, president of the group for many years. We gave birth to this organization. You see Devnexus now, so it's flourished into a beautiful thing. I don't have anything to do with it, and haven't had anything to do with it for probably 8-9 years now. Turned this thing over to folks that are really running it professionally, like Pratik and Vincent and others. So it's really kind of nice for me to see the baby grow up, if you will, and doing very well as an adult. Because if you know what I mean by that, I actually have 3 adult children. And so getting them into adulthood is not easy. Like feed themselves, clothe themselves, shelter themselves, that kind of thing. And Devnexus is definitely doing that at this point in time. But Java at age 25 years, think about it, right? We've gone through our toddler phase, our preteen, teenage years. Java's now a young adult. It's a millennial. Think about it, a millennial. So, it's probably wants stuff, okay? But at this point, it's a fairly mature technology. But we've been hearing a lot about Java being dead. If you're in the Java community, you're like, yeah, Java's dead. We've been hearing that for a long time. As a matter of fact, I went back to 2006 when people started talking about Java being dead 14 years ago. So we've been thinking it's dead for a long time, yet it is by far and away still more robust and happening around the globe than ever before. I travel the world at this point, going to different conferences and meetups and Java user groups and customers around the globe, and Java is booming. Not just Devnexus, which is booming, right? Everything like Devnexus around the globe is booming. And we have new conferences, new events, new meetups showing up everywhere around the globe, new customers moving more workloads than ever before. So it's not like when people say, hey, COBOL's not dead, right? Because it's not, but COBOL is kind of not necessarily going anywhere either, right? It's doing okay, but it's not growing. Java, on the other hand, is growing, all right? Java's doing exceptionally well. So if you actually look at some of these indices, like the TOB indice, right? They're basically say Java's still #1. If you look at RedMonk, they put Java up there with C++ and JavaScript, right? And as far as how they rate it. Now, this is kind of microscopic, so you can't really see it, but there's Java right there as #1. Over here on the RedMonk, right? JavaScript, Java, things like that, C++. And even down here with the cool kids, right, at HackerRank, they put Java as #2, even though they like JavaScript more. So it doesn't really matter what your survey is, Java is still there, okay? Java's still happening and it's actually growing. So if you have a career path in Java, in my case, literally 20 plus years of Java, it's still a good place to be. And I can actually say Java. I just had this conversation with someone who's been a long timer like me from the Java community from here. I said, I have to think about it. Java has literally raised my children. They fed my children for 20 plus years, right? So I like to think of it like that. Okay, so Java's still going strong, still doing very well, but we are showing our age a little bit. I don't know about you, but I'm definitely showing my age at this point. Because what ends up happening, okay, is Java's had all this amazing stuff going on in its ecosystem. It has a great set of tooling, a great framework technology, an ecosystem, all this wonderful bounty of goodness that Java can consume. So Java's been pulling all these technologies in, and it's actually amazing, all the stuff it can do. But like all of us humans, if you consume too many cakes and donuts and all that wonderful stuff, you start putting on a little weight, okay? And that's just what happens. Now the good news is, as humans, as you get older, you're allowed to say, I'm just 10 pounds heavier than I was 10 years ago, right? They actually do that. You get 10 pounds for every 10 years. I might be breaking that rule, but you get 10 pounds. Well, in our programming languages and our programming runtimes, we really don't want to add weight if we don't have to. Yeah, sure, you get more CPUs. I get that argument. We got more CPUs and more memory. It's cheaper than ever before. Grant you that, right? Our laptops, 32 gigs of RAM, 6 cores, 8-core machines. Yeah, we can throw more hardware at it. But there are times when you don't want to throw more hardware at it, okay? All right? But one time is when you put this thing in a Linux container. So you see my little container right here? We put Duke in there with his nice cakes and donuts and ice creams. When you put it in a container and you basically start to constrain Java in that container, because that's literally what a Linux container can do. A Linux container is just another process running on the host, okay? And because it's just another process running on the host, you have this thing called C groups. C groups, and it's the Linux kernel. So it's a Linux thing, right? Linux and the Linux kernel and C groups basically says that process, we can constrain that process to a certain number of cores and a certain amount of memory. Because that's what it's a Linux thing we've been able to do. It is not new to Linux. As a matter of fact, we had this with Solaris zones, and we had jails, and we had all this other technology that existed, in the ecosystem before Linux really took it on. But with Linux, this is a pretty cool feature. But the problem is when you do that to Java, right? If you have Java 1.8, I think 1.4.1 and older, it blows up. So if you're actually getting in your logs OOM killed, look for that, OOM killed, this is what's going on. Okay, on a Linux machine. This is what's going on. As a matter of fact, you really notice it if you build a Docker image and do a Docker run, and on that Docker run, you do a -m, which means memory constraint. Or if you use Kubernetes, and I can show you the file, and you have a deployment YAML, and you have a memory constraint. Or better yet, if you have a Kubernetes cluster managed by someone else, you're not allowed to specify that, you're just a developer. The systems administrator and operations team has specified that constraint, and you have to live within it. Okay? And what happens is at the Linux level, it's not Kubernetes, it's not Docker, at the Linux level, if you try to go beyond the boundary of your memory consumption, you will get killed. You get shot in the head. And the good news is Java, and especially Kubernetes, it restarts. right? You get shot in the head, you restart automatically. So you just see the log, and you're like, my process restarted. I don't know what happened. My pod restarted, but it seems okay. This is what's happening. OOM killed. Look for that. Okay? And Kubernetes has really cool features from this perspective. I've actually had software managers tell me, you don't understand. The fact that Kubernetes restarts these JVMs automatically is huge. My operations team is constantly restarting JVMs. Okay? My JVM is constantly either getting locked up or running out of memory. And you're probably thinking, how's that happening? Shouldn't happen in Java, right? But there's this little thing called a try-catch block with a finally. Back old school Java. I'm talking old school Java, right? Yeah, we have this thing called exceptions. And we have this finally thing. And we forget to use the finally part. Basically, we have a try-catch where we said, connect to that database or operate this thread pool. And we do some stuff that blows up. And we forget to put the thread or the connection back in the pool. And guess what happens to the application? It locks up. It's still there, still running, but it won't process any user request. So if you've had that issue, Kubernetes might be your answer because it automatically restarts the locked up thing. It's pretty awesome. It's like you got a walking zombie, it knows to shoot it and it had to respawn it. It's pretty cool. In any case, this is a real problem in the Kubernetes world because when you shove all these guys in containers, you really notice these constraint issues. You notice all these OOM kills in your logs, right? You notice all these issues that are happening throughout the infrastructure. So you see it a lot. Whew, was that fun so far? We're going fast. Look at that. That was only 11 minutes. I'm trying to keep you guys awake. Tell you a little story. We'll go and show you a bunch of code in a second. Here, let me tell you another story. I want to take you back to 1999. All right, so I actually started doing open source Java presentations in 2001 to this organization here in Atlanta. It was basically struts. You guys remember struts? We talked about struts. We talked about POI. There was no Spring back then. There was no JBoss back then to talk about. But we talked about struts, which was really the first thing that people got into open source. Up to that moment, though, right? We're talking 2001. We lived in this world, 1999 world. I'm only going to take you back this far. Some of you are like, I wasn't even born yet. I appreciate that, all right? You might not have been born yet. But we had something very special that happened, right, in 1999. We won the World Cup. Do you guys remember that? When I'm in Europe, people go, no. You don't even know what a World Cup is. You don't even know how to play that game. Might be true, okay? We did win the World Cup. And I want you guys to think about, if you're kind of confused at this moment, I want you to think about the cognitive bias that you might be experiencing at this very moment, okay? Because we did win the World Cup in grand fashion. You might remember this image from Sports Illustrated. We killed it, but the ladies won it for us, okay? As a matter of fact, we just won it again last year. We won it 3 times. So actually, the World Cup level, on the ladies' side of the house, we dominate. But I make that point because I want your head kind of in this mindset, because 1999 was not only important for Brandy Chastain here, and I say this, I coached soccer in this community, and I ran a girls' soccer program in Gwinnett County for 700 girls. I coached my own daughters. I coached girls for 14 years. This was a seminal moment. This was a moment, right? So there was another moment in 1999, though, okay? In 1999, if you wanted to build Hello World as a web application with Java, and I was one of these people who might have sold this to you, okay? I actually have met some of my old customers here at this conference. They're like, wow, you still have the legacy crap I sold you. I'm sorry. And actually, the other guy, I don't see him in the room, the other guy who was running around in that era who was selling WebLogic at the time. I wasn't selling WebLogic, but the WebLogic guy, I don't see him. But yes, so if you can, Tad who's running around, you can blame him. In any case, back then, you would have to buy a SunSpark server, about 18 grand. I actually called up friends and said, can you find your old price books? All right, can you kind of help me back with this? Yeah, $60,000 for a simple BA WebLogic, license for that server, the app server. And then maybe I had to have a database server. We were doing this client server, multi-tiered thing. So you had a database server, and then you had an Oracle license. That's the most expensive item there, right? You had to have an Oracle license. We weren't using Mongo and MySQL and Postgres back then. We were all using Oracle, right? Our own Windows servers, all SQL Server. And then, of course, you had to pay $50K, $10K a developer for the IDE. You guys probably don't even remember this era. But to get a developer started, right, a single developer might cost you $500,000 to get going. This is the world we used to live in 1999. So we were very concerned about memory consumption, CPU consumption, and the fact that these developers cost so much freaking money and we got to upgrade our laptops. Oh my God, right? It was an issue. It was a very big issue back then. And the reason I make that point is because that's not the world we live in any longer, okay? We now live in a world where we pay for these CPUs and that memory for so many cents per hour. So many cents per hour. We don't have to have a $500,000 outlay to get started. We now basically just go launch a VM in the cloud, and we now spend a few cents per hour. A very different mindset. But more importantly, one was a capital expenditure, meaning sunk cost, like we bought a building, and even if we don't use the building, because people, that stack I just showed you, I knew people who'd never used it. They bought it but never used it, okay? Because they just couldn't, like in one case, I literally met someone here in Atlanta who couldn't afford the programmers anymore because they spent all the money on that junk. Seriously. Like, we spent our budget, we got a bunch of stuff, we don't have a single programmer we can hire. Like, yeah, then you kind of made a mistake. But in any case, at this point forward, right, you basically now put this stuff in a place where you have to pay for the memory and CPU. It's an operational cost. They're OpEx, not CapEx. So you now notice that you get a bill for this on a monthly basis. In the other world, you're like, money under the bridge, right? Spent. In this world, you're like, I got a bill this month, and a bill this month, and a bill this month, and it seems to be going up every month. How's that happening? All right? So you notice. All right? Another little history lesson. We won't spend a lot of time on this. But if you actually think back Java back to 1996, going back to Java there, okay, and earlier, right, Java 1.0, you can kind of see that HTTP, the HTTP that we all know and love, was 1997, okay? So here's the world living on the internet, living on the web, and HTTP was really 1997. Red Hat Linux, which we're famous for at Red Hat, was all year 2000 as an example there. BSD jails was basically where you saw this concept of containers really coming to a foreground and coming together. Agile in 2001. EC2 in the cloud, born in 2006. So you can kind of see, right, that a lot of things were happening back in the early 2000s. And what we're talking about today is built on a foundation of all these innovations over these years. If you can imagine the world without HTTP, can you even imagine that, right? But it wasn't that long ago that we got HTTP 1.1 out there as an example. But then in 2011, 2012, so 2011, we had the concept of the fat jar introduced to us by DropWizard and VertX. Okay, the fat jar, meaning bundle everything in a jar file. We had new middleware that came out in 2012 for Hystrix and Ribbon. You guys are probably still thinking, oh, I might want to use that Ribbon thing. It seems pretty new today, right? You know, it's a Spring Cloud annotation now. So for some people, literally, I've just run into people like, oh, got to use that Hystrix thing. It's brand new. It's already been deprecated. That's how old it is. In any case, microservices defined. We also have Docker. And this is when it got interesting. We had Docker born in 2013. That changed the world. That moment changed the world. As an 8-minute presentation at a Python conference where Solomon stood on stage and said, I'm going to show you this new thing. And it's the Linux container, but what I've done is I made it insanely easy and given it a packaging structure and a real cool command line to it. Watch, D-O-C-K-E-R. And he lit the world on fire in a 5-minute lightning talk. Okay, at a conference, a small conference, not a conference nearly as big as this one or as important and influential as this one. So Docker lit it up, okay? Spring Boot was also born in the same time frame, and that's kind of how many people here use Spring Boot at this point? Like almost everybody. Yeah, okay, see? That 2013 happened right there. Also, microservices were officially defined by the ThoughtWorks team in 2014, and Kubernetes was born in 2014. So these things happened all at a very certain window of time. People were thinking about the cloud. They're thinking about their next generation of applications. Someone said microservices. You said that must be next generation. Oh, there's a new thing called Spring Boot, and I can put that in my Docker and run it on my Kubernetes. And the world shifted vastly at that moment in time, okay? Very dramatically. So that was up to 2015. Something else also happened in 2015, and I'm just making this point because this is something that's important to this presentation. In 2015, you can go to the URL there at the bottom and see the presentation that myself and a group of people put on at Red Hat. We basically did two things. One, we did this really amazing Bluetooth tracking thing where we tracked people around the conference with Bluetooth signals and Raspberry Pis. It was amazing, right? It was actually very cool. But we also did a little mobile thing, built mobile apps, deployed mobile apps because mobile was hot back then. But the more important part of it was we were challenged by a bunch of people in the company, and I do these big, grandiose keynotes like you might have saw this yesterday morning. Burr, we want to see you launch 1,000 servers live on stage. That was the task we were given. And I had to think about that pretty hard. It's like, wow, launch 1,000 servers live on stage. And so we were moving to Kubernetes. This was all Kubernetes. OpenShift was born on this day with Kubernetes as its core architecture. And we were thinking, yeah, we can scale to 1,000. Let's figure that out. And we killed ourselves for several weeks as we figured it out. But when we launched 1,026, and I can tell you why 26, but 1,026 containers live on stage in 2.5 minutes, in this presentation, which you can see in the video, nothing has been sped up or edited, right? It's real time on stage. You will notice that I walk away for a couple minutes, talk to someone else, and come back, and it's done. It was really about 2.5 minutes. We basically did that with Node.js, okay? I'm a Java champion, been a Java user group leader for many years, started a Java conference, and it hurt my feelings a lot to have to do that demo with Node.js, because that was the only way we could start 1,000 application servers live on stage. Couldn't do it with Java. Java won't start 1,000 JVMs in 2.5 minutes, okay? So we've been thinking about this problem for a long time. And so that's where Quarkus, the idea, right, came in. Can we find a way to make Java fast and small like Node.js? And as a matter of fact, if you saw the keynote presentation yesterday, can we even make the developer experience as smooth and sexy as Node.js? Like, edit, save, refresh, edit, save, refresh. And again, a Node person's like, that's the way the world works. Java people are like, oh my God, right? I used to tell people we're actually crashing the coffee quantities of the world, right? Because people aren't going to take breaks anymore because they're used to doing, oh, I made a code change. Let me take a break while it builds. No, edit, save, refresh. So this was another part of that equation. Can we launch 1,000 of these things? Okay? And so another thing that's happened in the last few years, and so these quotes are notable, right? Someone asked on the internet, good thing, getting advice on the internet can go either way. But someone asked on the internet, hey, I want to build Amazon Lambda components. I want to do that with Java. I want to do it with Spring Boot. And people are like, hell no. Don't use Spring for that. And it goes further. Don't even use Java for that. I just talked to a person who does Lambda work. Like, yeah, I can't use Java for that. And we were finding that we had a lot of customers in the modern era who are like, I can't use Java anymore. I got to move to Node. I got to move to Python. I got to move to Go. I got to move to C++ because Java is too fat and slow. Okay? And so we thought about this really hard at Red Hat, and we basically gave birth to Quarkus at this conference last year. A lot of people don't know it because it was a quiet unveiling of what we did with Quarkus, but we gave birth to it at this conference. If you actually go back, there's some videos online of me talking to people here. We showed it in our live demonstrations here at Devnexus as an example. So we had been thinking about this problem, and we think we have an answer. Move this out of the way. Okay? So we're going to show you this Quarkus thing. We already saw aspects of it when I showed it in the keynote yesterday. I assume most people saw the keynote yesterday, right? So we can show you a little bit of that, but I want to show you more advanced things now, okay? And if you saw Edson's presentation, that was more advanced technology, and I want to show you more advanced things in this session. All right, so Quarkus is vastly smaller, vastly faster. Your mileage will vary, depends on your use case, but I would say just go to the public website, quarkus.io, and you'll see different little benchmarks and things that we've done there. So in some cases, it is a lot faster. As a matter of fact, here, let's go there real quick, just to kind of show you what I'm talking about. So Quarkus.io, all right, and just scroll down here. You kind of see, look, traditional fat jar app, maybe 136 megs of RAM. With Quarkus on the JVM, Quarkus on the JVM, 73 megs of RAM, and Quarkus all the way compiled to native, 12 megs of RAM, right? So it might be, that's a significant savings, and now that you get a bill for that monthly, see in the old days, 1999, no bill, sunk cost. 2020, right, 2020, you get a bill. So people notice now, all right? So people notice. Startup time. If you want to do serverless technology, you're going to start a lot. If you're using Kubernetes and containers a lot, you're kind of starting a lot. You're starting more often than you ever thought. As a matter of fact, we used to pride ourselves as Java developers of never having to restart our applications, right? We have no downtime. We never restart that application. We only restart it like every 3 months. We got really good at writing that code. We didn't have the try-catch-flying thing I mentioned earlier, right? We didn't actually have the static variable used too often. I actually had to fix a bunch of people's code. They were like, it's running out of memory. And this is back in the days when we only had hash tables. Anybody remember back that far? We didn't have all this fancy stuff we have now, right? And they had basically declared all their hash tables with the static keyword. Think about that for a second. Everything they shoved into those hash tables just stuck around forever, right? So they just kept filling up memory and you couldn't figure out why. But we think about that now, right? We pay for that memory. And so think of your startup time, think about the memory there, and that's really why we focused on this technology, right? How do we make it vastly faster to start? And again, that's at quarkus.io, right? That's just the main website there. Let's see, where were we here? This one, yeah. I can see a couple of people have joined my presentation there. That's how I know you joined. It's a live document, okay? A couple more slides and we'll kind of get into this more fun stuff. Is this entertaining at least so far? Well, we got to keep you entertained, right? That's the most important part. Okay, let's see, low memory usage, fine, all that good stuff. We kind of showed you a lot of these things. All this is here. We'll kind of keep going. Very much focused on Kubernetes. When you saw me actually add that Kubernetes plugin extension, and then I deployed it to Kubernetes, we are thinking in terms of Kubernetes first as an architecture. Can you run Quarkus on VMs? Yes. Can you run it on bare metal? Yes, right? It's pretty much anywhere a native executable will run or anywhere a JVM will run, right? Which is everywhere. But at the same time, we were focusing on these Kubernetes OpenShift style use cases to basically run in that architecture because that's where we're getting the most customer feedback, right? Like we have to move everything to Node.js or everything to Go, okay? All right, so let's kind of jump into this. That's a whole dissertation on the world of Linux containers, which you can kind of look at on your own. This also talks about the history of serverless. Serverless has actually been around as a term since 2012 as well. So serverless is not a new thing either. And we've been thinking about how do we do serverless better. Lots going on in the serverless industry there, okay? And these are the charts that you saw on the website. Let me kind of fast forward here to get to the part that's a little bit more interesting, and I want to mostly get into code mode. Okay, Grail VM. Oh, I guess one thing, how many people here use Kubernetes already, by show of hands? All right, not many of you. So I just want to kind of explain it just so you hopefully understand the context a little better. So Kubernetes has this concept of a master node. Basically, it has an API it exposes, and that's where that kube control apply-f you saw me use, right? Here's my YAML, throw the YAML document at Kubernetes. So that's the nature of Kubernetes. It takes your YAML document, or JSON document, but YAML document, and it knows to basically make the world look like the document. It's a declarative architecture. You basically say, I'd like 4 of these and 2 of these and 1 of those, and they connect them this way, and boom, throw the documents over the wall. The document lands in etcd, right? That's the database where it holds it. And then the schedulers and controllers look at the document and figure out what to do with that information. And so this all happens asynchronously and through a reconciliation loop. These schedulers and controllers are looking at the document in the database, they're looking at etcd and going, yeah, I see what you want. Let me see if I can go make it happen, okay? That's what it's trying to do. It's very clever technology, and it is kind of eventually happening here. It's async, and it does this at great scale, right? So the idea came from Google. Right? Google launches 2 billion containers a week. At least that's what they used to say 5 years ago. They might launch more than that now. So, how do you do this at scale, right? Was this architecture. And so you can see there's these worker nodes, and these worker nodes might have my Tomcats out here. So I have my 3 Tomcats, my Spring applications, my Wildfly, my SQL Server, my whatever it is. It doesn't really matter. As long as it runs on Linux, SQL Server is great, right? Running on Linux. It can run in one of these worker nodes, okay? And these worker nodes basically run the job. So these guys are taking your request, making it happen across those worker nodes. And if you have a request like, give me 2 replicas of this customer service application. So like here, you saw me actually do this yesterday, now I think about it, right? I did the query.io, here's the image, pull the image. You say how many you want. If you want any labels, configuration, called a config map. That's the data that's in the declaration. It goes through the API, lands in etcd. And then it basically talks to the worker nodes and say, hey, can someone handle this? And the worker nodes basically spawn those 2 additional Tomcats in this case, right? So you can see them showing up there. So the worker nodes are like, okay, we got it. And so the worker nodes are telling the master, done, got that job running, all right? And so if you look here, okay, it's always watching. Kubernetes is always watching. Not only do we say up front, we want to have 2 of these things. If for some reason something dies, like that one right there in the middle, okay, it knows to respawn it someplace else. It looks for death, meaning it's just gone, right, because the application could have died. It also looks for stuck, meaning it's there, but it's not really responding anymore. And this is actually a hugely powerful aspect of Kubernetes. It has a liveness probe and a readiness probe. And if you misconfigure those things, you can cause havoc, okay? Especially the liveness probe, because the liveness probe basically is a ping, if you will. You can actually just make an HTTP GET, or a little look at the file system. You can even look at the file system and say, are you alive? I'm looking for files. I'm just doing a get on a URL. And if it responds correctly, it basically assumes you're alive. If you don't respond in the right time or with the right answer, okay, it assumes you're a walking zombie because you're there, but you're not responding correctly. If you're a walking zombie, shoot you in the head and restart you someplace else, okay? So it's a really powerful concept that's part of Kubernetes. And so that concept is very nice, but in a Quarkus world, right, we wanted to figure out if we could get greater application density. So the pod magic did not shrink. And this is actually funny. So when people got Kubernetes and OpenShift, they're like, oh, great, I'm using pods now instead of VMs. I only have to give the application like one core and no memory. I had this happen with customers. One core, no memory. I'm like, what do you run, when you ran on a real computer, what did you give it? Oh, 4 cores and 8 gigs of RAM. And you think some magic happened because you moved that thing to Kubernetes? No, okay? You can't give it a Raspberry Pi to run on and expect it to run well. And so I've had this discussion a lot. So you still got to give it memory and CPU. That's not changed. So you got to make the process smaller. And that's what Quarkus does. So can I get 20 of those things instead in the space of 2? Okay? Make it smaller. So 10 times smaller, 100 times faster. Again, it depends on your use case, but we'll show you some things. Okay? Also, a couple other things. Cogito, if you actually use declarative business rules or declarative business processes, if you like BPMN, right, business process modeling notation, and things of that nature, declarative syntax for doing decision tables as an example, think of an Excel spreadsheet, and that's your if-then-else logic, that's Cogito. And again, it's been shrunk down and packaged and made ready for Quarkus. I have a whole demo on that if we want to see it later. All right, small RAI is also where we're doing a lot of the implementations for this technology. So just be aware of small RAI. It's doing some interesting things around reactive, which we're going to see today. We're going to see some small RAI stuff, okay? If you look at the reactive world, though, that we're now moving into, you should be aware of that reactive programming is one tiny aspect of it, all right? So the reactive programming you can almost kind of ignore if you choose to, because it's not necessarily the most important thing. The more important thing is that you're non-blocking and async, right? That you want to be non-blocking and async, and there's a lot of ways to get a programming model that gives you non-blocking and async. There's actually a lot of ways to get a different runtime architecture to get you non-blocking and async. And we're going to talk about some of those things. But see the Reactive Manifesto there, the manifesto word? The manifesto basically talks about how to build a reactive system. And you should be thinking systems holistically. Think in terms of my system, not any individual piece of code or even a component of an application, but how can the system be more reactive and more resilient and more elastic and respond better to errors within the infrastructure, right, within the system. In other words, if something dies, does the whole system die? And you're constantly thinking about that in this reactive world. But reactive programming is certainly part of it. There's a lot of different ways to do reactive programming in the Java world. You also will see reactive extensions through RxJava, Project Reactor as an example. And reactive streams, part of macro profile, and reactive messaging is what we're going to focus on. So I'm going to kind of focus more on that bottom right thing a little bit more today. All right, so micro profile reactive messaging, that's the URL. This is kind of what the syntax looks like. We're going to jump into this and do some fun stuff. But incoming and outgoing, look how easy that is. We try to simplify the programming model. We try to make it where you're doing reactive, you don't even care that it's kind of looks normal, okay? Because if you see normal reactive programming, like from a Node.js community, the code looks like this. It starts slanting off to the right because you basically have a callback within a callback within a callback within a callback, and you can't understand it anymore, right? And if you've ever done that with Node, as an example, because that's where some of these ideas came from, then you were like confused. But then there's lots of ways to solve it. This is one way to solve it, basically saying we have an inbound data stream, we have an outbound data stream. And that's all we're really doing. In this case, is just logging it out, okay? So we're going to see some examples of this. You can do this with Apache Kafka. Okay, Kafka or MQTT or AMQP, like an ActiveMQ, AMQP. Kafka is the one I'm going to show you. And then you can see these are all the reactive capabilities that are kind of part of the Quarkus ecosystem. The thing to note up front is Quarkus is built on this thing called Vertex and Netty. So at its very core, not only is it small and fast, it's purely reactive at its core. Even though you can write imperative programming logic and lay it on there like normal, okay? Normal Spring imperative stuff, normal JAX-RS imperative stuff, normal servlet kind of imperative stuff, right? Old school code, it's actually still reactive at its core, okay? So one thing to keep in mind there. So reactive messaging is the thing I'll focus on. There's also a special reactive router that actually comes from the Vertex world. If you're familiar with Vertex, I did a Vertex presentation here like 3 years ago. That's the same kind of technology there. And there's reactive APIs to the database. So reactive database interaction, that was just pretty cool. It also comes from the Vertex world. So a lot of what you see here is Vertex +++, and kind of come up from that perspective, okay? So this is the demo I'm going to show you. Oh, and actually, let me show you one thing real quick. This is actually very complicated. Let me show you this not so complicated thing, again, to give you, let's see if this works. Okay, this is actually, let me show you the code here, a Quarkus application. It's a Quarkus application I did not show yesterday, and sometimes I just don't show it, I don't have time. But this is a Quarkus application based on Spring syntax. Okay, so if you're familiar with @REST controller and @AutoWired and things of that nature, all right, web bind, things like that, patch mapping, delete mapping, get mapping, things like that, AutoWired. So if you're familiar with Spring Web, Spring DI, Spring Data, those kind of annotations, what we've done is we've mapped them into this microscopic subatomic world that we're living in Quarkus. So if you have muscle memory for these things, and you're used to typing @get mapping as opposed to @get, okay? Because the equivalent of this, let me see if I have one. The equivalent of this is, okay. Yeah, let's see here. I probably have a to-do. I probably have a ton of things out here. Let's see. I actually built one of these things on the fly recently. Oh yeah, I was actually in Romania at Halloween in Transylvania. So I think I called it Dracula. Let's see if I, yeah, this looks like right, okay. Yeah, here's an example, right? So this is the micro profile JAX-RS way to do things, okay? And a lot of people don't, does anyone here know the syntax? Anyone use it? A few of you, okay. The IBM guy, I understand, appreciate that, just picking on you. But how many people know this syntax? Okay, right, the rest of you. So this is, that's why we added this language, if you will, is so you can use your language. You speak this language. This is just another domain-specific language for doing a web-based router. Think about it. How to hook a URL to a piece of code. That's all it is. There's other ones, too, in this system. So with this one, I've already done the compile down to native. You should have saw that when I did that yesterday. And I haven't done this in a while. But let's check this out. So this is that application. Compile to native. Spring to-do runner. Go. I already have something on 8080. Yes, hold on, let me fix it. I can fix it. I think it was this guy running on 8080. We'll come back to him in a second. Yeah, all right, let's go here. One more time. I gotta remember that. Look, so this is that application, that Java Spring-based full create, read, update, delete against the database, building the database schema from scratch, right? 0.03 seconds. And it's a little slow, we can improve upon that. So that is the world we're living in now with Quarkus, right? So this incredibly fast startup time, and of course you can use your imperative programming model. This is the imperative programming model, no problem. But here we're going to talk about the reactive programming model, okay? And I just want to show you one aspect of the reactive programming model. So just keep that in mind, and to make, this application is actually kind of interesting. Let's see here. Nope, I don't have it there on that URL. I think it's here. Yeah, fantastic. 1, 2, and it's on the PG admin. So this is actually running against a real Postgres. Let's see if I remember how I set this up. I haven't looked at this in a while. Is it I think I called this thing DB Kona. Let's see here. Tables, to do, view the data. Let's see. There's my 1, 2. Okay. So it actually generated the whole schema connected to the database, all that in 0.03 seconds. So if I come over here and say, love Java, right? And I want to basically say, learn Quarkus, do be OpenShift Kubernetes, right? All that kind of stuff I've been talking about here, but I can't even spell correctly. We like to say OpenShift, don't forget the F, right? You guys get it? All right, but right here, there we go. Okay, so it's a full working application, started in 0.3 seconds. Okay, so it is a real deal app, and so a lot of people go, oh, it's Hello World. This is not Hello World, this is for real, right? Okay, so that's cool, but let me show you this other thing. The thing we're gonna show you now is this crazy complicated demo. It's actually not super complicated, except for the fact that I'm trying to run everything by myself. Okay, so we're gonna see all these windows. We're gonna talk about all these windows here for a second. All right, so I think that's probably gonna be okay. Let's go here, we'll come back to it. Okay, right, so what we have, in order to kind of make the point of what you might do with this reactive streaming kind of architecture, all right, I have a producer over here that's gonna just poke in some JSON. You saw that when I demoed it right at the front of the presentation. It pokes in some JSON, that's all it does. It has an API for talking to the Quarkus, the Kafka message broker, right? Kafka message broker. It pokes that JSON into a topic. It's just called a topic for giving it a name. There's a consumer to show you the consumer side of that. So producer, consumer, that basically is using a WebSocket to stream it out to the browser. So every message that goes in streams out to a browser, right? Which is kind of cool. You get to see the message flowing on that side of things. And then there's this transformer here in the middle I call that the in-out. And its job is to receive the input on A topic and output on B topic, right? Its primary job is basically, I'm receiving the stream, I'm manipulating the stream, and pushing out a new stream based on what manipulations and transformations and filtering I have done. And that's really where the reactive programming kind of comes in. We'll see a little bit of that. And then there's the output over here that is the result of that other stream, the B stream, okay? That's going to be a server-side set of events, basically another push to the browser, so you can kind of see the data comes in, goes out, right? That's the goal. So I actually listed the names of the projects here, just so you can get it. And actually, I just realized I didn't even put where this thing is in GitHub. Let's actually add that real quick. Let's see, GitHub, this is, I think, what do I call this thing? I got so many projects out here. Kafka, yeah, this is the Quark to Kafka. This is actually I can show you this Knative one again. This is the one I showed you yesterday. But this is the one we're talking about here. So let's go here. Let's just add this real fast. Yeah, okay, right there. Look at that. Like I said, live slide updates. And if you guys have access to the deck, right, you now have that information. So right there, bit.ly Quarkus Java. All right, let's kind of show you this application and see if we can make heads or tails of it. All right, first of all, this is Kafka right here in this window. So this is my Kafka broker running with Docker Compose up. It's just my Kafka broker sitting there. And then, so let's kind of pull up some windows here. This is my producer endpoint. It produces messages and just reflects them to this screen right here. So if I hit refresh, you notice that it says customer 2 now. Hit refresh, it says customer 4. And it's just, you notice the data payload is basically the same. I was just finding a way to pump some JSON in, that's all. And I just want to see if this little system would work. Let's see, here's the output of that. This is the subscriber, okay? So if we look back at the chart here, it's these two things right here, okay? That's occurring right there. If we look at the Java code for the producer, let's get rid of that one. Let's get rid of that Spring one. And that one, the XRS one, don't need that one anymore. Okay, so we got to come over here to the producer, and specifically this one. If I look at the Java file, very straightforward. Okay, when I do a get on that URL called produce, it basically has this concept of an emitter. So this is already one of the APIs that's kind of cool. When you want to bridge from the imperative world to the reactive world, this is the way to do it. Okay, you go through the emitter. And so basically, the reactive world is just at path, at get mapping, path, all that normal stuff, restful stuff you're used to. That's the imperative programming. And now I wish to bridge into this reactive world, and emitter allows me to do that. So I'm going to create this JSON object, but you can see it just has a little simple counter here for the customer. It's very straightforward, but it is emitter.send. Okay? Now you should be aware that in this scenario, there's no automatic back pressure. All right, so back pressure, if you guys have not heard that term before, all the reactive people are all geeky about it. It's like, ooh, I got back pressure. And do you have back pressure? I've got back pressure. How much back pressure do you have? And it's really irritating when you go to some of these presentations, right? It's like, oh my God, you don't have any back pressure. It's like, what are you talking about, okay? So back pressure is a very simple concept. If you have a producer, let's call it like a radio broadcast station, right? You're producing content, events, data streams to the world. You're broadcasting, right? You're producing content. On the other side, you have a consumer, a receiver. You're tuning your dial into that radio station. You're listening in, right? With back pressure, if you happen not to be listening at that moment in time because you turn the radio off, right? They know. And they will hold the stream of the radio station until you tune back in again. And as soon as you tune back in, you pick up right where you left off. Now, this analogy I just made up on the fly, by the way, right here. So this might not work at all. Does this work at all? Kinda? So it's real simple. It's, when you're in your traffic jam here in Atlanta, all right, and you're listening to that really good article or segment on NPR, and then you pull up to your driveway and you pull in the garage and you got to get to your child's soccer practice right now, but you don't really want to turn off the radio station. You want to hear the rest of the story. You guys with me? So that's really where these concepts come from, I think, right? It's the concept you have a producer and the consumer does not want to miss anything. They don't want to, drop a message, if you will. And we have this with messaging infrastructure as well. The difference is when you have a broker in place, like an ActiveMQ or a RabbitMQ or something like that, that's handling the back pressure more or less, right? Basically, producers are throwing messages at it. The broker is writing them to disk like a database. And the consumer is like, oh, I'm tuning in now. Give me a message. Give me a message. Give me a message. And if the consumer is turned off, the radio station, they're turned off their radio and they went to bed, okay? When they wake up the next morning, those messages are still queued in that broker, all right? So that's what a message broker does. It handles this stuff. But with back pressure, you're trying to basically say an input stream is going to react to my output stream, okay? Now, this is a case where it does not. The emitter has its own special buffer built into it, and if you overflow that buffer, you will run out of back pressure. So just keep that in mind, all right? The emitter is to bridge the old world to the new world, okay? So we'll show you a different example here in a second. So that's the publisher. So that's the publisher that basically when I hit this button over here, this one, right? No, not that one. This is the problem, this complicated demo, right? When I hit this button, you can see that's the count plus plus. That's the publisher, pushing a message in, okay? This is, of course, the ultimate receiver over here. Let's see, there we go, right? So every time I push a message in, some crazy stuff comes out the other end, okay? Some transformed message comes out the other end. We'll kind of walk our way through that. Now, over here, we have, let's go back to our chart, our diagram here. Dun, 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 dun. Okay, let's talk about this guy here, the consumer web service, just so you can see consumption, basic consumption in this case. So let's go to the consumer web service, okay? Oh, I forgot to tell you something. It's actually very important. See right here where it says @inject, and actually we just changed this to @channel. It's no longer stream, and I have the older API and I didn't have time to change it. So channel is the new annotation there. See where it says my stream? If you look at application.properties, there's my stream right there. So already with microprofile specific syntax here, right? You basically say, I have an MP, microprofile, messaging outgoing, the name of the stream, and that string right there is what you use in the Java code, right? So if you call this thing Burr, you got to say Burr there, okay? And then you have a connector. You can see this is small right Kafka. We want to connect to Kafka. It's this topic. This is where my Kafka is running. And by the way, all of these parameters you see right here can be overridden at runtime through environment variables, through your deployment of your deployment YAML if you're doing Kubernetes. So, it says localhost right now because I'm in development, but I override that when I send it out to a cloud or send it out to my Kubernetes over here or over there. And the cool thing is, getting a Kafka running inside of OpenShift is actually very easy. Here, just to kind of give you an example of that. Here, let's see, where am I at right now? No, let's not go there. Let's go here. Kubernetes, what is my current namespace here? That one says Burr. Okay, so we're in the kube namespace Burr. Watch kubectl, get pods in Burr. And let's see here, kubectl. This is kind of off to the side, so forgive me if it gets too confusing. Grab Kafka. One of the things you can do is extend your Kubernetes with all these awesome APIs. Like you can have Kafkas as in your OpenShift, in your Kubernetes. You can have pizzas, beers. It doesn't matter what it is. In this case, I have Kafkas. And so if I come over here and add a little YAML to it, right? Let's see, get Burr. Where is it at? It's out here in one of my repos. It's just a piece of string that I need. Script, let's see here. Yeah, kube files. I'll just grab one of these. And let's see, OpenShift. Yeah, let's grab this one. And actually, it says Devnexus already because I made that change, so let's leave it like that. I'm going to just take this YAML and see it's just declarative state. That's what the Kubernetes power is, declarative state. I want a Kafka, please. So kubectl apply, -f, and I want a Kafka. And so what's happening now is that document is being downloaded into my cluster, into my etcd. My controllers and schedulers, and this thing's called an operator. It's a very special controller scheduler. It's kicking in, and it's basically saying, you want a Kafka, right? And if I say get Kafkas now, as opposed to get deployment or get pod, right? It says you want a Devnexus cluster with 3 Kafka brokers and 3 zookeepers. So it's trying to make that reality now. And so we'll give that a second. Hopefully I put it in the right namespace. I probably did not. Let's actually, let's see if we put it in the right namespace. That's probably one problem, because I'm looking at a certain namespace to see this thing show up. But that concept is kind of how you might get a message broker as an example. All right, so when I say you want to deploy localhost, so there it is, the Kafka is coming to life, right? Again, and think about that, that's kind of magical. How many times as a developer have you said, I'd like to have a Kafka broker to work with, and your operations team's like, yeah, file a ticket for that and get the vice president to sign off? Yeah? You feeling that pain? The beautiful thing about having a Kubernetes backend, an OpenShift backend, is that it's all managed by an API with governance, right? Quota. In other words, if you have the right OpenShift cluster, Kubernetes cluster, you basically say, I want to launch one of those now, and no ops team, no tickets to file. That's the point of self-service. It's the point of this technology. So it's coming to life now, and I'll have a full Kafka to work with, and I can do all kinds of crazy crap. And that code I just showed you earlier, right? Right here, I would just change that to whatever the server is over there. That's all, okay? Instead of localhost. But that's basically, you just have to look for this my stream, and over here, whoop, well, not that one. Where'd it go? So my stream, right? My stream. All right, so let's kind of keep walking through our way through this. This is actually, which one is this one? Oh, this is the server-side event. Yeah, let's come back to that one. And we saw the WebSocket one. So let's actually get to the meaty one here, the fun one, and spend some time there. Where is it? This one? Yes, this one. Okay, this is not a live code scenario because I'm just not that prepared for that, but it's a live commenting, uncommenting. How about that? Okay, all right. So right now, let's go up here to the very top of this piece of code, and let me just uncomment this one. All right, so what I want to do is receive the input. Remember, this is the input-output thing. I'm just going to log it out, all right? And it says input Burr there. So let's say we put input, Fred. Is there a Fred in the room? No? Okay, well, Fred's not here. I don't know who Fred is. I just made that up. But I want to input, right, my input, and then I just want to log out the message. See the message is coming. So I just made a change. And remember, I told you earlier, right, Red Hat, right, Quarkus, edit, save, refresh. Edit, save, refresh. So let me go back over here. Let me get to the right window. Got to be in the right window here. There we go. And I'm going to basically just refresh it. And now I just need to push a message into it. Okay, so let's come, where's my little user interface? And not that one. And this one. Okay, let's put that over here because we need to see some things here. And let's see what happens here. Okay, so when I hit refresh over here, notice what's happening. See this little message is showing up here in the bottom? That's the logged output. So basically, that's all it's doing right now. Receive the stream, log it out. Receive the stream, log it out. As each message comes in, just log it out, right? No big deal there. All good. And I also can just curl it from this side if I want to, make it a little bit easier for myself. And all I did right over here is when I called this reset method, basically the reset method is just the rest URL. That's the refresh. And it reloads that code base, which I'm looking at. So that's a simple logging out. Okay, so let's actually get a little fancier here. Let's do this. Let's not consume it that way. This is where we can kind of do some interesting things here. Let's see, that's a returns a flowable. That's not that interesting. Oh, let's try this one. I can't remember if I tried this one recently, but let's try that one. Okay, input to output. And why is that saying? What?
Your previous incoming didn't comment.
Oh, no, yeah, we can't do that twice. Thank you. Yep. Look at that, even live commenting, uncommenting. I can't keep it this straight. All right. So let's see, the input goes to the output in this case. Let's see how that works out. And in this case, again, I want to live reload it. So let's just call that reset. Let's push a message in. Okay, message goes in. It says right here, successfully sent to B topic. Right there, sent to B topic. Let me come back over here. That's B topic is this guy right here. Yeah, that one. Okay, so we should see messages showing up over here. Let's see, can we make this? This is the problem with doing these things, right? You can't get enough real estate on screen. There we go. See the message showing up here? So it's just taking the entire input and sending it to the output. And that's what we're seeing over here. So it went from A topic to B topic, just straight up, no modification of the message. And that's all this was really doing at this point. So you can kind of see the programming model is pretty straightforward. Pretty kind of simple, right? And that was one of our goals with this, was to basically make it simple. A fellow named Clement on our team basically worked very hard on these kinds of things. And so, and Clement is one of my favorite people. So come on, stop that. We did that. Now let's kind of show you something a little bit more fun, all right? Let's kind of show you one. If you have errors in your stream because you've done something, you actually have a bad payload, if you will. You have something that you put in there that's not quite right. You can actually have some, now you're starting to see the reactive programming, right? Right? Oh, look at that. I forgot they added that to our IDE. But you can kind of see right there, this concept of a flowable from ReactiveX. So the idea is I now can have an API that allows me to see each message, do on next, as well as if there are any errors associated with it, okay? So are there errors associated with it, then you would see that. But let's worry about that one later. I want to kind of show you a more fun one. Let's show you this one right here. This is where we're actually going to change the message on the fly. And I have fairly simple logic here. So the inbound message, right, flowable input right here, that's the inbound message. I'm going to return that input as my flowable output, right? I know it's kind of hard to see there, but my flowable input becomes my flowable output. After I do this map, and a map basically says, take the record, right? Take the record that's coming in and transform it. And this is a simple transformation. It's just dealing with strings in this case. I purposely did not use any JSON-B or anything weird, just to keep it really clean. And then you can kind of see if there's any do on next and any errors, do on error, right? What's the error handling for this stream processing? And you kind of see basically it takes the JSON, parses it out, it grabs the ID, and it puts in aloha dude instead. So I mentioned earlier I'm from Hawaii, right? But let's go, hey y'all here. Let's see if hey y'all work for me. All right, and not dude, but I guess we got the y'all here. So this should be the y'all. There we go. Let's see here. Dun, 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 dun. All right. I'm just transforming the message. In this case, it's completely replacing the message that came in with what's going out. So full transformation of that message. So if I did that right, I can do a reset here. Fantastic. I can push another message in. Okay, but my UI is down. Let's get the UI back up here. Over there we go. But do you see the hey y'all at the bottom? So pushing messages in. Okay, there they are. So a full transformation of that message, basically input, output. So I really like this programming model. I've done a lot of messaging-based systems throughout the years, enterprise service buses, things like that. And I think this is actually very cool and very powerful. The nice thing is too, remember that back pressure thing I told you about? It's handled for you. If you're running out of gas, your input, on your input side, and your output is too slow, right? The system can handle that. It kind of knows how to deal with that. So back pressure kind of built in. You kind of get that for free, but you don't have to think about it. That's what I like about it. You just basically have your input, your output, okay? How about another example here to make this a little bit more interesting? Let's see here. Let's comment that back out. This one's a little bit more fun. We can actually skip, right? Ends with 8. See where it says ends with 8? We want to basically only process customers that have an 8 in the number. See the filter right here? So you have all this additional syntax that are part of these reactive operators. Right? So if I come over here and say I want to do dot, you kind of see there's all these different reactive X operators. So filter is one of them. So I want to only look for messages that have an 8 and process the ones with an 8. Okay? I might only want to look for messages that hit a certain come from a certain customer. You can kind of see that all this is in here. Okay? As part of it, as part of that API. So I think that's actually very powerful, very fun. And let's take that out, right? We don't want to mess that up. But that's what it's doing. And actually, let's reload that. Let's see, we can go here. And so in theory, if we did that correctly, okay, we should only get messages that end in 8. Let's see, end in 8. There we go. One with 8 at the end. The rest are just dropped, okay? Because that's the only ones I care about. Cool thing about a topic, multiple people can be consuming on that topic, listening for the data they care about, processing it accordingly. Just like dialing into a radio station. I only want to listen to the station I care about, or the shows I care about on a certain station. Same kind of idea there. Let's see what else we got here. I know we're nearly out of time, but let me kind of show you that crazy one we did towards the end there. Okay. Oh, and actually, where you're filtering, actually, this is a good one to show. See, this does the same thing with the 8, but it actually has a filter method and an accept, and you can kind of see the accept really has this return of a Boolean. So in this case, I really can have really crazy logic associated with that filtering concept, right? Same thing with the transformation. That's your map, right? Map is your transformation as an example. So let's not worry about that one. And let's add this special K thing, right? So this is kind of a fun one. Now we're really seeing a transformation of the message in kind of more dramatic way. All right, let's come here. Did I do that one right? Yeah, I think I did that one right. And let's see, reload, edit, save, refresh. There we go, push a message in. Let's kind of get our output up here, right here. Dun, dun, dun. So it adds special K to it, right there. See the special K? So again, augmenting the message pretty dramatically. And let's hit the punch, the grand finale here, which is the one I showed you right up front. I want to also inject the extended prices. So this one's kind of crazy, more advanced, if you will. All right, so there's a lot going on here. But if you kind of walk you through it, pretty straightforward. Again, you have your incoming, your outgoing, right? Your input, your output. You basically create, I'm just using strings in and out and using the JSON-P stuff to basically read it, parse it, whatever. All right, I can add an ID to the new object that's being created, that class special K. I can create these two arrays for the order details, right? That's an array in there for the order details. I'm going to loop through all the order details. I'm going to grab the quantity. I'm going to grab the price. And I'm going to basically have an extended price being added right there. Extended price, add it to the JSON, and push that out. So that's what we saw earlier. If I come over here and do a reset, okay, and then come back over here. And if I get the message in correctly, dun, 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 and okay, come on. So let's see, right? Sometimes, let's see, did I get disconnected? Yeah, that's not right. Not right. All right, let's see, that one. One more, come on, reload. I know, coming up. Maybe, working, not working. Oh, it's not working. Oh, man, where'd it go? Let's see, I had this working earlier. You guys saw it earlier, right? Wow, man, what did I leave out? This, even with live commenting, uncommenting, I still made a mistake in here someplace. Okay, well, we can figure that out later. But all right, we're basically out of time. This was working moments ago, okay? But here we go, wrap it up. If you need access to this presentation, again, the bit.ly Quarkus URL, get you access to this, bit.ly Quarkus Java, get you access to the presentation. You can find me on Twitter. If you have questions, I can take them in the hallway because I know we're over time at this point, but thank you so much for your time. Was this cool?